Hello everyone. Today we're gonna learn how to graph linear inequalities. So I'm gonna jump right into it with an example. So I'm gonna go from standard form, ax plus by equals c, and I'm gonna change it to slope-intercept form, y equals mx plus b. First thing you need to understand is that if your equation or your function looks like this, it's probably easiest if you change it to look like that, okay? Because we can graph y equals mx plus b a lot easier. Now, let's say your graph already looks like this, then you're good. Just start graphing, okay? I'm going to do the harder way, and I'm going to start with the standard form equations, and I'm going to switch it or transform it to y equals mx plus b, okay? So example 1. We have 3x minus 2y less than 10. Okay, so let's go ahead and make the changes. We're going to subtract 3x to both sides, and you're going to get negative 2y less than negative 3x plus 10. You can't combine the negative 3x and 10 because they're different. This has an x and 10 doesn't. Now we're going to divide by negative 2 to both sides. Now when we divide by a negative, what happens to the inequality symbol? We flip it. Y flip. Oops. Flip it. And you're going to get 3 over 2x, because a negative and a negative is a positive, minus 5. Okay, and we just flipped it there. And this is our equation. We need to graph this, okay? So I'm going to just draw a little. Actually, I wonder if I could change this to graph paper. Oh, cool. We have graph paper. Okay, so let's graph this. Our coordinate plane, x, y. And the first place we're going to start, and I'll use a different color ink, we're always going to start with the y-intercept, the number that's by itself. So we're going to start at negative 5. 1, 2, 3, 4, 5. Okay, that's negative 5. Now, according to this, we're going to rise 3, and we're going to run 2. So we're going to rise 3, 1, 2, 3, and we're going to run 2. 1, 2, 1, 2. And there's our point here. Now, before drawing the line, remember that inequalities that do not have the line under them are dotted lines or dashed lines, how the book says. If they look like this, greater than equal to, less than equal to, then they're solid lines. So in this case, it's a dashed line. Do a dash. Okay, so simple enough. We've done these before. Now, the big thing here is finding out where to shade. Just like we had open circle, closed circle, now we're going to have shading above or below. So the best way to do that is to just pick a point at random and test it out. Okay? So I always like to pick 0, 0. And you're going to see what I mean by that right now. We're going to plug 0, 0 into our function right here. So I'm going to write that down here. Y, I already forgot. Y less than 3 over 2x minus 5. And I'm going to plug in the point 0, 0. So I'm just going to put this here so I know what we're doing. So for y, we put in 0 greater than 3 over 2, x was 0 as well, minus 5. So I plugged in 0, 0 because if that point gives us a true statement, then we know that that is a solution, and then we can shade. So we have 0 greater than, what's 3 halves times 0? 0 minus 5. So 0 is greater than negative 5. Is this a true statement? Is 0 greater than negative 5? Yes. It's a true statement. That means 0, 0 is a point, is a solution of the inequality. So that means we shade the point where 0, 0 is. We shade this whole area right here. So what that is saying is that if I pick another point, let's say right here, that's negative 4, 1. If I pick this point and I plug it in here, if I plug this in for x and y, it's going to give me a true statement like this. Okay? That means it's part of the shaded region, and which we know it is. And that's how you graph linear inequalities. Pretty straightforward. The only new piece of math, I guess you can say, is really understanding where to shade. Other than that, it's the same thing as you've done before. Okay? Thank you.